stuff like that. And thanks for letting me know, Aaron. No worries. In case you didn't catch what I was talking about before, just read the email I sent yesterday night, and if you didn't receive that, just let me know as soon as possible. But it covers what I'm going to do about the homework packets, like the 2 homework packets that have already been assigned. Also future homework packets, which basically won't exist as of right now, and then also exit tickets. Okay, so now we're going to move on to our 3rd day of optimization problems, and today we're just going to basically going straight through practice problems. So yesterday we started working on like harder optimization problems, I'd say. And I think the structure I taught them was kind of confusing. So I came up with like a better structure. And I guess this is like, I feel like when you look up how to solve optimization problems, this is kind of the way they teach it. So I'm going to try to go with this. Okay, so can I get Renique? Would you be able to come off mute and just read the first problem for us?
Let x and y be 2 positive numbers such that x plus 2y is equal to 50, and x plus 1 times x plus 2 is a maximum. Find x and y.
Awesome. Thank you so much, Renique. Great job. Okay, so I would like for everyone to write this down in their notebooks. You don't have to write down all the words, but just like get the idea of the problem. So you can say something like x plus 2y is equal to 50. We want to max out x plus 1, y plus 2. Something like that. This gets the entire gist of the problem without writing out all of the words. But I'm going to give everyone like 20 to 30 seconds just to get the problem down on paper. Okay, so basically the structure for solving these types of optimization problems where we kind of have to figure out our own equation is we're going to kind of clarify which is the constraint equation and which is the optimization equation. These are the 2 steps that I feel like when people teach optimization that people really focus on. These I kind of just added. I removed these steps later on, if you notice. But for right now, I just have the constraint equation and optimization equation bolded, and then the steps for like solving the equation more clearly outlined. So for our constraint equation is basically, I guess, the equation that constrains our problem. In this case, it's x plus 2y is equal to 50. And we can think of this as the constraint equation because it's kind of restricting our possibilities, right? We're told that x plus 2y is equal to 50, and there's no other possibilities. X plus 2y must equal to 50. And yeah, that's our constraining equation. And also, we know that it's not our second equation, which is x plus 1 times y plus 2, because this is the equation that we're maximizing. It's not constraining, we're trying to maximize this. So I would like for everyone to write down at least these two parts, the constraint equation and the optimization equation. Okay, so we're going to move on from the constraint equation to the second significant step in optimization problems, which is finding the optimization equation. So when I say the optimization equation, I'll clarify this to say it's the equation we want to maximize or minimize. So we're given, if you look at reread our problem, right? We're given this equation saying that x and y are two positive numbers and it must fit into this, right? X plus 2y is equal to 50. But we're given a second equation that we're told that we want to maximize it. So we want to make this value like as large as possible while still fitting within the standards of x plus 2y is equal to 50. So essentially, the equation that we want to maximize in this case is going to be f is equal to x plus 1 times y plus 2. So we want to maximize f, basically. We want to maximize this value, x plus 1 times y plus 2. Okay, give everyone a few seconds just to catch up and hopefully internalize that. Okay, so our next step now, usually it's not as clear, like when people teach optimization problems, these are the two things that they focus on, the constraint and optimization equation. But I'll say the next step is we tend to want to eliminate a variable or somehow combine the equations, right? Because we have two equations, right? And usually when we have two equations and we have two variables, because we have x and y, right? And we have two variables, it's a good idea to see if we can somehow combine these equations so that we can actually solve for one of the variables. So in this case, let's just take our constraint equation, which is x plus 2y is equal to 50. So instead of x plus 2y is equal to 50, we're going to write that as x is equal to 50 minus 2y. Right, so now we call x. We now substitute x for our second equation. So now we're only with y. So f is y plus 1 times y plus 2. This is going to take us to f is equal to 51 minus 2y. 51 minus 2y times y plus 2. And then, so I'm just going to actually rewrite this as 2 plus y, just so it's easier for us to FOIL it, or to visualize multiplying everything out. But 51 times 2, 102, plus 51y, right? So we're multiplying 51 times 2, then multiplying 51 times y. Then we're going to multiply negative 2y times 2, so it's going to be negative 4y. And then multiplying negative 2y times y, so minus 2y squared. So then we're going to have 102 plus 47y minus 2y squared. So each of these, we're just basically multiplying it out. Yeah. So I think it's important to remember that what we're dealing with here is f, right? Zakaya, you have your hand raised. Do you have a question? You can come off of mute.
Yeah, I have a question from where it says f equals 50 minus 2y plus 1. Where did the 1 come from?
So, sorry, which step are you talking about? Are you talking about over here?
Yeah.
Yeah, so we're essentially substituting in, right, x goes into here, right?
Mm-hmm.
So we have 50 minus 2y goes into x, but we also still have this plus 1 here. So we can't forget about that. So that's why we have 50 minus 2y for the x, and then you just add the 1 that's still over here.
Okay, I understand now. Thank you.
Okay, sounds good. Okay, so next, I think it's important to remember that we're still dealing with f, right? This is still f, and f is the equation that we want to ultimately maximize, right? We decided that over here. We want to optimize, or in this case, specifically, we want to find the maximum, so we want to maximize f. So how do we do that? With any function, if we want to find the maximums and minimums, we're going to find the critical points. And to do that, we are going to find the derivative. So we're going to find, I'm going to rewrite f is equal to negative 2y squared plus 47y plus 102. Daniel, do you have a question? You can come off of mute.
Yeah, how did you get to, what do you call it? 10 squared plus 47y.
Oh, sorry, this is a 102. This is not 10 squared.
That's 102? Oh, okay.
Yeah, so it's 51 times 2. So that's 102.
And the 47, how you got the 47 too?
So 47 is 51y minus 4y. And then we got 51y again by multiplying each of these steps out. So 51 times y is 51y. And then we also have negative 2y times 2, which is negative 4y.
Okay. And you did a subtraction?
Yeah, so 51y, then you would subtract 4y to get 47y.
Okay.
If it's more clear, I think sometimes it's easier to visualize it. Like you can rewrite this as negative 2y plus 51 times y plus 2. I'm also more used to working with equations in this form. So then it'd be like you multiply negative 2y times y, so negative 2y squared, negative 2y times 2 minus 4y plus 51y plus 102. So that might make it more clear. But yeah, I'll leave that there for, so we ultimately get negative 2y squared, sorry, not, plus 47y plus 102. But so now we have this equation and we want to maximize it. So our first step for finding the maximum and minimums for the critical points is finding the derivative. So we're going to derive this. So f prime is equal to, we can just apply power rule throughout this whole thing. So negative 4y, we're going to bring the 2 down and multiply it by negative 2 and then subtract 1 from the exponent. So it's negative 4y to the first, the negative 4y. then the derivative of 4y is just going to be 4. Oh wait, sorry, I have this written down wrong, I think. I was looking at this and it does not look right. So it is 47y. So negative 4y plus 47. And then to find the critical points, we always set our derivative to be equal to 0, and then we solve for our variable, right? So in this case, negative 4y plus 47 is equal to 0. So then we'll go to negative 4y is equal to negative 47. Right. So negative 4y is equal to 47. We're going to divide by negative 4 on both sides. So we're going to get y is equal to negative 47 over negative 4, or 47 over 4. So this is going to be our critical point. Which means it's either going to be our maximum or minimum, right? We really quickly reviewed critical points yesterday and how critical points give us a 0 slope, right? And 0 slopes in a function, they happen either at like the tops of the hills or like the bottom of valleys, right? So that's why setting a derivative equal to 0 will give us critical points that are either maximums or minimums. Right, so 47 over 4 could be a maximum, right? It could be like over here at this type of point, or it could also be a minimum. It could be at this type of point, right? So ultimately, we have a critical point, but the question now is whether it's a maximum or minimum. So what we're going to do is set that number line, right, to find out. So we're going to check our answer, check our critical point, you could say. So we're going to plug in a number to the left of the critical point into our derivative equation, right, to find the slope, right? We're just finding this derivative equation, again, is just finding the slope. So let's plug in, if I plugged in 0, right, I plugged in 0, I get f prime is equal to negative 4 times 0 plus 47. That's going to be equal to 47. So that's positive. Right, now I'm going to plug in a number over here. Let's say could do 12, I guess. 12 would be 48 over 4, right? So f prime is equal to, I'll just make this, so 48 over 4 is more obviously to the right, just to the right of 47 over 4 plus 47, and that should be equal to negative 1. So basically I know the slope going to 47 over 4 is positive and going away from 47 over 4 is negative. So basically I have 47 over 4, right? And going up to it is positive slope, and that is negative. So that, what does that tell us? It's going from positive to negative. It must be a maximum. Sorry, the notes are so like cramped here. Yeah, this is a lot of, it's actually really messy, I think. Sorry about that. I'm gonna, so hopefully that. So now we know that our equation, the maximum is at y equals 47 over 4. Right? Now our final step is to plug it into our constraining equation, right? We're told that x plus 2y is equal to 50. So we can just plug in y there to figure out what x is equal to. So x, oh, sorry, 1 sec. Say x plus 2y is equal to 50. X is equal to 50 minus 2y. So that's equal to 50 minus 47 over 4. 2 times 47. Let me write that. Minus 2 times 47 over 4. Which, to be honest, I don't know what that's equal to. I'm going to do the calculation really quick just so we can get an answer. So it should be equal to 26.5. So we have y is equal to 47 over 4 and x is equal to 26.5. So this is our final answer. So when we're meeting these two, when we're constrained by x plus 2y is equal to 50 and we want to maximize this, the way to maximize it is by saying x is equal to 26.5 and y is equal to 47 over 4. So hopefully that makes sense. So Samantha, you sent me a different answer. Did I do the math wrong? I might have done the math wrong. I just used my iPhone calculator. I think it's right. 47 over 4. Oh, gotcha. Okay. Yeah, so 47 over 4, I guess, is 11.75. But then we need to actually solve for x. So it'd be like 11.75 would go into here. So it's 50 minus 2 times 11.75, which I think is 26.5 because we're solving for x. So hopefully that makes sense. Make sure you have this written down because I'm going to erase it in like 1 second, just how I just plugged in y to solve for x. Awesome. So I'm now going to have you guys try to attempt this second problem, which is the product of two numbers is 185 and the sum is a minimum. So find these two positive numbers. So I'm going to give everyone 1 minute first to figure out what the constraint equation is. So this is the equation whose like standard, whose criteria we have to meet. It's not the equation that we are minimizing or maximizing. It's like, I guess like the arena that we have to play in. We can't have these two numbers be completely random. They have to meet certain criteria. And I will say this problem is slightly harder because there's an extra step. In this problem, they just gave us the equation straight up, right? They told us that x plus 2y must equal to 50. This one, they do it in like a word problem format. So it's not as clear what the constraint equation is. So I'm gonna give everyone 1 minute. And if you figure out the constraint equation, I would like for everyone to send the equation into the chat that you get. you, Anik. So I'll scroll up just so you guys can see this for reference. So in this case, they tell us that the constraint equation, let x and y be two positive numbers such that x plus 2y is equal to 50. So that's telling us what these two numbers must be equal to. So it has to follow this rule. It's constrained by this rule. In this case, second problem, there's a different rule that these two numbers must abide by. It's constrained by this rule. Awesome, thank you, Mercy. Thanks, Aaliyah. Thank you, Derek. So it's really not as complicated as you might think. It's just reading the problem and figuring out, like, there's not a lot of like multiplying or adding or like different manipulations you have to do. Awesome. Thanks for everyone who's answered so far. Okay, can I get Derek and Mercy? Would you be able to come off of mute and just share what you think?
Hello.
Hi, Derek.
Yeah. I thought it was x plus 35 and y plus 5.
Gotcha. And just how did you get 35 and 5?
Because it said the product of two numbers is 185. So I look for the factors that added up to
Okay.
that.
Okay, cool. And then Mercy, do you agree or disagree? And then what your answer is.
I disagree. I said x times y equals 185.
Gotcha. Yeah, so that is the correct answer. I think it's easy to kind of overcomplicate these problems, or at least this one. All that we need to focus on for the constraint equation is that the product of two numbers is 185. That's it. They tell us that the product of two numbers is 185. So let's say our two numbers are x and y, right? We used x and y before. So that means x times y, xy, is equal to 185. That's all it is. Because we're told in the first sentence of the problem that the product of these two numbers is 185. That is our constraining rule, I'll say. That's our constraint equation. So when we go to the second part, we want to find a sum that is a minimum. We have to follow this rule. X times y is not allowed to equal 186 or 2,000 or 1 million, right? It must follow this rule. It must follow x times y is equal to 185. So hopefully that makes sense. Give everyone 20 seconds. I realize I didn't give you guys time to copy down the problem, but if you can do that now. And if you have any questions, make sure to just raise your hand whenever you want. I think with these optimization problems, probably the first most important step is getting the constraint equation and the optimization equation down. Otherwise, it's impossible to get the right answer.
Wait, is that a to y equals 185?
It's xy. Xy is equal to 185. Right, so we're told just in the first part that the product of two numbers is 185, and it's very simple. That's the rule. We have to follow by that. Awesome, thanks, Kiana. So for the next part, I'm going to give everyone 1 minute to figure out the optimization equation. So now it's the other part of the problem. What are we trying to optimize? In this case, we're trying to minimize it, right? So what equation are we trying to minimize? In this first problem, right, we wanted to maximize this, right, x plus y times y plus 2. In this case, it's a word problem, but we want to minimize an equation. Awesome. Thank you, Mercy. Thanks, Kiana, again. Thanks, Aaliyah. I'll wait for a few more answers in the chat. So I'm going to cold call really quick. Can I get Reese and Mercy to come off of mute?
I'm not sure what to do. I don't understand the lesson.
Okay. Okay, thanks for letting me know, Reese. Okay, Mercy, what are your thoughts on this?
I just know like x plus y because it said that the sum is a minimum. So like you're using the same variables, and it's not the product, so it's the sum. So you just add x and y, and then that's the equation.
Yeah, that's exactly right. So for this first, we're just essentially doing, we're trying to minimize f is equal to x plus y. So just to show an analogy for this first problem, we were told that x plus y times y plus 2 is a maximum. So we're trying to make this as large as possible. So we're trying to make f is equal to x plus 1 times y plus 2, the exact same equation. We're trying to make it as large as possible. In this case, we're told that the sum is a minimum. So the product of two numbers is 185 and the sum is a minimum. So we're using these same two numbers, x plus y, right, because that's a sum. And now we're trying to minimize this. So hopefully that makes sense, Reese. Again, we're just taking this like word problem and just getting two equations out of it that we can use. Again, we start off with just saying the product of two numbers. So we know we have two numbers that we're dealing with, right? And then we're told that the product of them is 185. Okay, cool. So I can just write that xy is equal to 185. I know this. This is concrete information, right? This does not change. X times y is equal to 185. And then I know I'm trying to make the sum a minimum, right? So I'm trying to make f is equal to x plus y, because this is the sum of x and y. And I want to make this a minimum. So that's the equation that we're trying to optimize. We're trying to actually like make it as small as possible, make x plus y as small as possible, while still adhering to this criteria so that x times y is still 185. So yeah, I'm going to really quickly take us through the rest of the problem just because there's not much time left. But I think the first important step is getting the constraint and optimization equations down. So I'm going to solve for the answer. Just try to write down all of those steps in the notebook just so you guys have it. But I want to optimize x plus y, right? F is equal to x plus y. But we have two variables, so that's kind of confusing, right? X and y is That's two variables. That's like too much to deal with. So we can substitute in one of the variables using our constraint equation, because we know that y is equal to 185 over x, right? I just divided by x over here. So I'll write out all those steps. xy is equal to 185, divide both sides by x, right? So that is equal to y is equal to 185 over x. So now I'm going to put 185 over x into here. So then we're going to get f is equal to x plus 185 over x. So I'm actually not sure I'm going to get through this entire problem, but I'm just going to try to get as far as possible. Now we want to find f prime, right? Because we have our equation now, right? We want to find the critical points. So before I find f prime, I'm going to rewrite this so it's easier to do power rule. So f is equal to 185 over x, which is equal to x plus 185 x to the negative first power, right? Because these are equivalent. Over x is equal to x to the negative first power. Now if I want to do power rule, f prime is equal to 1, right? The derivative of x is 1. And then, wait 1 second, x plus y. Yeah, so 1 plus 1 minus 185 x to the negative 2, right? Because I multiply the coefficient 185 by negative 1, and then I subtracted 1. So that's just power rule. Sorry, my handwriting is so messy. 85 x to the negative 2. To find the maximum and minimums, we're then going to set this equal to 0. If I set this equal to 0, I'm just going to really quickly manipulate this. So 185 x to the negative 2, right? And I'll write this over here. 1 equals 185 x to the negative 2. And this is equal to 185 over x squared. Right, so then I can multiply both sides by x squared. Right, so then I get x squared is equal to 185, which then tells us that x is equal to root 185. So I'm going to stop right here, but then our next steps would be to do the whole number line thing, right? Figure out whether square root of 185 is actually a maximum or a minimum. If it was a minimum, it should go from negative to positive, right? So then I can verify that x is actually a minimum, and then I can find y just by plugging in x back into our constraint equation. So this is we're like really close to the answer. We just kind of have to double check our answer by doing that whole number line thing. So x is equal to root 185. You can just have that circled. But that's going to be it for today. The exit ticket is probably going to be pretty challenging. So I'm going to grade for accuracy, but like if you do one of the exit ticket problems is going to be pretty hard. So if you do that one wrong, like I'm not going to take off many points, like maybe like a point out of the 5 points or a point and a half. But also, regardless, I'm still releasing like the tutorial video. So if you watch through that, you should theoretically be able to do both problems. Mercy asked me a good question, which is how do you know which equation to find the derivative of? So we are always trying to find the derivative of the optimization equation, right? Because that's the equation we're trying to maximize or minimize. Does that make sense? So we always, like, when we solve for X or Y, we always want to substitute it into this equation, the optimization equation. This equation is just our, like, constraining equation. The optimization equation is the one we want to focus on because that's the one we're going to want to maximize and minimize. But yeah, hopefully that makes sense. If anyone has any questions, feel free to stay after class. But that is basically it for today. Just turn in your class notes, do the exit ticket at some point tonight. I'm going to have the video out by the afternoon. So yes. And then again, make sure to reread through the email. Yeah, Renique, go ahead.
I have a question.
Yeah, go for it.
Where do we get x equals x plus y from? I mean,
Sorry.
in the second problem.
Yeah, so our optimization equation, we're told that, okay, so you get the constraint equation, right? The product of two numbers is 185, right? The next part is that we're trying to minimize the sum. So we're trying to minimize x plus y, right? Does that make sense? And then I just said it equals f just so it's like more clear, but I could say it's equal to anything. It's just that this isn't.
Okay, so
yeah.
Are we always going to try to find the maximum or something?
In this case, it's asking us to find the minimum, right? But it's the same process.
Okay. Okay, thank you.
Yeah. Yeah, sorry, Kiana. Do you have any questions, Kiana?
No, I'm just copying this down.
Okay, sounds good. Let me know if you have any questions.